y equals ln x squared. Find y prime. Okay, so we have done derivatives of e's. We've done derivatives of bases that are not variables. We've done derivatives of bases that are variables. We've done chain rules. We've done quotient rule, product rule, power rule. But we have not done, we've done trig. We've done inverse trig. But what we have not done is logs. Okay? Now, ln x is just log base e of x, correct? That's what we said. It was just log base e is 2.71, blah, 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 blah. Keeps going, right? So we're going to do the derivative of this one. So this is a chain rule, correct? Because it has the 2 outside. This is like our f would be x squared and our g would be ln x, right? Because there's that g embedded in the f. So we have to do chain rule. So y prime equals 2 ln x, technically to the 1. But I don't need the 1, but I'm proving a point. Okay. Now we have to do the derivative of a ln. Okay? A ln or a log. They're all the same. A ln is just log base e of x. Okay? What you do is you rewrite it in the denominator. You're going to get a fraction every time you take a derivative of a ln. So you rewrite it in the denominator. Ln the base. What happens with ln e?
1.
Goes bye-bye, yep. And then the derivative of what's beside my ln in the top?
1.
Now, we don't actually write the ln part, we just write the x. This is how people will write it every single time when I get it on a test. You don't actually write the ln. It's like when you do trig, correct? When we do trig, when we take the derivative of what's inside, we actually just write the derivative of what's inside. We're not going to write sine of it. So this doesn't actually exist. So what you do is you take what's beside the ln, put it in the bottom, the derivative of it on top, ln e. So you don't write ln x. I get that all the time on tests. That is not true. All right? You just write what's beside the ln in the base, the derivative of it in the top. The ln actually goes away unless it is a log. Right? Because ln e goes away. But if it was like log base 4, then this would be ln 4. Okay? So unless it is a log, you actually don't end up with any lns behind it. So this would result in 2 ln x over x. You could say x can't. Actually, x has to be what? Can't equal 0 because of the denominator. And what does it have to be? Can you have a negative beside a log?
Restrictions.
You have to say x is greater than 0. All right. Then we have 2. Y equals 1/2 log x. What happens when I just have a coefficient? You just rewrite it and the derivative behind it, correct? If you wanted to, you could treat it like a product rule. Remember, that's why I showed you how it actually works. The coefficient just sits in front. Because if you do product rule, the derivative of a half will be 0, so the second half of the product rule will go away. So you don't have to do the product rule. You can just rewrite the coefficient. Now, I also told you whenever you see log x, always put base 10. And the only reason why I'm putting the base 10 there is so that I remember to go ln 10 in the denominator. So dy over dx is what they want me to find, not y prime. So dy over dx equals 1/2. And then the derivative of a log, this is a log, ln is just a log base e. You take what's beside it, put it in the denominator, correct? The derivative of it in the numerator, what's the derivative of x?
1.
1. And then we have to remember to put ln. So my answer is actually going to be 1 over 2x ln 10. 3. Ln x plus ln y equals 2x. What am I going to have to do here? Wow. In 30-1, you do synthetic division. True statement. Okay. Yep. You do synthetic division for polynomials, not for this. Implicit differentiation, which sounds very close to synthetic division.
That's why I was trying to
Yeah, they basically rhyme. Basically the same thing.
Does that mean that the US dollar is going up? Like Canadian dollar?
US to CAD.
US divided by Canadian.
So
If we have like a
Canadian money.
So
Oh my gosh,
US
okay.
is increasing or Canadian?
Derivative of ln x.
You want to.
No.
You don't want the...
We want it to be lower. No, our dollar is now worth less compared to the US dollar.
Because the US is on top.
Yes. Yes.
Okay, ln x. Derivative of ln x is... We write it on the bottom, the derivative of it on the top, and then I would technically get ln e in the base. And I write that every single time, just like when we take the derivative of e, because then if they give you a log that isn't a ln, you'll remember to write it, correct? So ln e goes away. Then I would actually technically have dx over dx, correct? I'm writing all these to prove a point. But they're just ones all around. Okay, then the derivative of ln y. I get a y in the denominator. The derivative of y is 1, and what must I follow behind with? And then it equals 2, technically, dx over dx. So, I'm left with 1 over x. Oh, bored. What?
Why is there not a lawn, like the lawn next to the Y?
Oh, there would be.
Oh,
It just goes away.
but there would be one there.
Yeah. Absolutely. So, we get 1 over x plus 1 over y, dy over dx, equals 2. What must I do then? So, I'm going to go 1 over y, dy over dx, equals 2 minus 1 over x. Then what do I have to do? Multiply by 1. Now what they'll probably do is make this have a common denominator. Multiply them both by x. So I'll get 2x minus 1 over x. Technically times y. But the y could just join the top, right? What?
Thinking about the US and
Oh my gosh, stop. Okay, 4. Y equals log base 2 of x squared.
No, because if we have one US dollar, it's worth
Okay,
or 2 Canadian dollars.
so if we have here, we're going to go y prime equals, if it's just a log, what's in beside it goes in the denominator, and then I get ln what? 2. And what goes in the top? 2x. Now, because these are multiplied, This x can cross off one of those. And I'm left with 2 over x ln 2. So,
You don't change
chain what?
the x squared, you can multiply 2x into it.
Okay. And then 5, we have ln 5x. So that's why this one isn't taught in chain rule, because it's not technically a chain rule, it's its own rule, right? Okay. Find y prime. Try out 5 and 6. So we have ln of 5x. So y prime would be, rewrite it in the bottom, ln e, ln the base always, just happens to be a 1. And then the derivative of 5x in the top, which is 5. So what are we just actually left with? 1 over x. Now, this one, what do we have to spot with 6? Product rule. There's a multiplication here, right? So I'm actually going to say f prime is 1. G prime is x squared plus 1 in the denominator, ln the base, so ln of e, which is a 1, and the derivative of that on the top, so 2x. So it's just 2x, x squared plus 1. And then we're going to do product rule. I didn't specify, so if you did y prime, it's totally fine. dy over dx. Okay. So I'm going to get g times f prime, which is technically a 1, plus f times g prime. I can put them all over x squared plus 1 because the x is over a 1, right? So I just get dy over dx equals ln x squared plus 1 plus 2x squared over x squared plus 1. Now some people say the x squared can go away. Incorrect statement. The x squared is attached to the plus 1, right? They're sewn together, so you can't take them apart. Now sometimes they'll leave it like this, and sometimes they'll make a common denominator and write it all over x squared plus 1. It's not going to make any difference. So tomorrow we do logarithmic differentiation. This is logs. So this is just when you're given a log, how do you do the derivative of it? Then there's ones where you'll spot them because they'll look like it's like a product within a quotient. Like the numerator will be a product rule, the denominator will be a quotient rule. There's got to be a better way to do this. It's called logarithmic differentiation. So it's actually way better. But this is section 3.4. And I want you to do numbers. Oh my gosh. Sorry. So problem. AP practice.
Can you call yourself by your middle name?
All right.
Maybe because it went up. Sorry, that's
9, 4, 11, 12.
like that's stock market stuff, not London stuff.
So weird. So
And
what-
17. Oh, there's a whole bunch more.
No.
1, 2,
John, have you been mad at you?
3, 4.
No.
Yeah.
I'm gonna erase this.
Oh, you're an evil child.
Yeah.
No, they just call you Messy John.
Oh, I know.
No, it's just like.
It's going to be 1 to 5. 5, please. 1 to 5, 7, 9, and 11 to 13.
But like the last time they did, you were really mad.